Have you ever wondered why Blender hasn't become industry standard software, despite its years of existence and the impressive results created by artists worldwide? In this video, we'll explore some of the key reasons why it's still not widely adopted by large companies. Number 1, the choice of software for 3D graphics and animation production is critical for studios, and many studios are cautious about adopting open-source tools like Blender. One of the primary reasons studios avoid Blender is its open-source nature, which, while beneficial for individual users and smaller studios, can present significant challenges for larger companies that develop proprietary plugins and add-ons. Open-source software like Blender is freely available for anyone to use, modify, and distribute. This freedom has made Blender popular among independent artists, small studios, and hobbyists who appreciate its flexibility in zero-cost access. However, this very openness can deter large companies and studios. These companies often invest heavily in developing specialized tools, plugins, and add-ons to enhance their software capabilities, streamline workflows, or create specific visual effects that set them apart from competitors. When a studio chooses a tool like Blender, which is open source, any custom add-ons they develop may be difficult to secure, as open-source projects encourage sharing and transparency. For big studios, maintaining proprietary control over their technology is essential for maintaining a competitive edge in the industry. If they use Blender and create plugins for it, there's a risk of these tools being shared, copied, or reverse-engineered by the open-source community. This fear stems from the fact that sharing the code for any plugin developed on an open-source platform could lead to it being accessible or replicated by other developers, including competitors. Protecting these investments is crucial, as these studios often spend millions of dollars and years of development effort to refine and optimize their software tools. Moreover, Blender's open-source license, the general public license, comes with certain requirements that can complicate plugin development. The general public license mandates that any derivative work or modification of the original software must also be open source and distributed under the same license. For a large company that relies on proprietary software and plugins, complying with this license can be a major drawback. If a studio modifies Blender's core or develops an add-on that integrates with it, they may be legally required to share the source code for these modifications, which they may not want to do. This is a significant deterrent, as many large studios and plugin developers wish to retain control over their intellectual property to safeguard their investments and prevent others from copying or benefiting from their work. As a result, most big companies prefer to develop plugins for paid, closed-source software like Autodesk Maya, 3ds Max, or Cinema 4D, where they can secure their code and do not have to worry about the complexities of open-source licenses. Closed-source platforms also often have larger enterprise support and offer legal frameworks that allow these companies to retain exclusive control over their plugins and tools, making these options more attractive from a business perspective. Blender's open-source nature is both its strength and its weakness. While it fosters innovation and accessibility, it also discourages major studios and plugin developers who need to protect their intellectual property. This tension between open-source ideals and proprietary needs is why large studios and plugin creators often avoid Blender despite its capabilities and widespread popularity among individual users and smaller teams. Number 2, industry standards and established workflows. In the 3D and VFX industry, certain software packages like Autodesk Maya, 3ds Max, and Houdini have become standards. Many studios have decades of experience and a well-established workflow around these programs. Maya, for example, has been widely adopted in the animation industry for character rigging and animation due to its deep customization, extensive plugin library, and well-known tool sets. Similarly, Houdini is prized for its procedural generation and effects, and 3ds Max is popular in game development. Blender, while powerful, is newer to the professional scene and lacks the same level of standardized reputation. Switching software in a studio setting is a significant undertaking as it would disrupt established workflows, which can be a costly and time-intensive process. Number 3. Integration with pipeline tools and asset management. Studios often rely on highly specific pipeline tools that integrate with their core 3D applications to manage assets, track progress, and synchronize data across teams. Many of these systems are optimized for software like Maya or Houdini. Blender's compatibility with these proprietary systems and third-party plugins can sometimes be limited or require extensive customization to make it fit seamlessly. For example, large studios often use asset management tools that integrate deeply into Maya or Houdini, and these don't necessarily have equivalents that work with Blender. Transitioning to Blender would mean a complete overhaul of asset management and version control tools, which is costly, and requires a dedicated team to maintain. Number 4. Custom tools and scripting limitations. Blender uses Python for scripting, which allows for a fair degree of customization. However, many studios rely on a combination of Python and C++ to create high-performance custom tools, often for software like Maya, which has an extensive API that supports both languages and allows for deeper integration. Maya's MEL, Maya Embedded Language, scripting and its Python API have become the standard for writing custom tools, while Houdini also offers support for custom operators in its network-based setup. Blender's scripting capabilities, while powerful, lack some of the flexibility and efficiency that studios look for when creating or implementing custom tools, which can make it more difficult to integrate Blender into a custom pipeline where speed and performance are critical. Number 5. Lack of support and training resources. Studios also consider support options and available training resources when selecting software. Autodesk and SideFX, for instance, offer extensive customer support packages, training resources, and certification programs. They also have large communities of professionals with years of experience, which allows studios to onboard new team members quickly and provides a safety net for resolving technical challenges. While Blender has a growing community in open-source support, it doesn't offer the same level of official, professional-grade technical support. For a studio, that translates to potential bottlenecks in case of bugs, software issues, or compatibility problems, especially when deadlines are tight. Number 6. Concerns about stability and long-term support. Blender is open source, which means its development and updates rely heavily on community contributions and funding from initiatives like the Blender Development Fund. Large studios, however, often prefer software with dedicated support teams and predictable development cycles, as this reduces risk. Autodesk, for instance, has a history of consistent updates and bug fixes with a corporate structure that provides guarantees for software stability and long-term support. Although Blender Foundation has been increasingly consistent in releasing new versions and improvements, studios are cautious about the potential for sudden shifts in focus or changes in the direction of development. Number 7. Interoperability with other specialized tools. The VFX and animation industries are highly collaborative and involve numerous departments working on various aspects of a project. Most studios rely on a suite of software that includes not only 3D modeling and animation but also compositing, Nuke, texturing, Substance Painter, rendering engines, Arnold, Redshift, RenderMan, and editing software, Avid, Premiere. The way Blender handles assets, scenes, and outputs can sometimes present issues when interfacing with other tools that are already deeply integrated with industry-standard software like Maya or Houdini. For instance, Blender's handling of Alembic files or FBX formats, which are often used to transfer animation data, sometimes lacks the consistency or feature parity that studios need. As a result, studios might encounter issues when attempting to transfer work from Blender to other software, creating more challenges for a collaborative pipeline. Number 8. Perception and brand image. Many studios, especially top-tier ones, have a brand reputation tied to high-quality, cutting-edge visuals. In the industry, Blender has sometimes been viewed as amateur software due to its free nature and association with indie or small-scale projects. This perception is changing, especially with the release of projects like the open movies sponsored by the Blender Foundation Spring and Big Buck Bunny, but it remains a consideration. For better or worse, studios often feel that using Blender could impact their perceived professionalism. Clients may question whether they're using serious tools, which could affect business relationships, especially if clients are not familiar with Blender's capabilities. Number 9. Rendering limitations. Blender's Cycles and EV rendering engines are impressive, with Cycles offering path tracing capabilities that allow for photorealistic renders. However, studios often work with highly specialized render engines like RenderMan, Arnold, or Redshift, which have decades of optimization for complex VFX and animation tasks. Render engines like Arnold have significant features that are critical to studio productions, including support for large-scale render farms, scalability, and advanced shading networks. While Blender does offer some support for external render engines, the level of integration is typically not as robust or seamless. Additionally, Cycles can be limited in handling some of the high-complexity render requirements, which makes it less suitable for productions with advanced needs, like those involving complex simulations or very large scenes. Number 10. Human resources and hiring preferences. One of the challenges for studios is finding experienced talent, and most 3D professionals trained in formal programs or who have worked in the industry are more familiar with software like Maya, Houdini, or ZBrush than Blender. Hiring artists and developers familiar with these industry-standard programs can often make onboarding easier and faster, as they require less training to get up to speed on the studio's pipeline. The lack of Blender training in academic institutions and certifications also impacts its uptake. While the Blender community is working to address this, studios still rely on an established talent pool that is predominantly trained on proprietary software. Number 11. Blender's open-source nature. Pros and cons. Blender's open-source nature is a double-edged sword for studios. On the positive side, it's cost-effective and highly customizable. However, open-source software often has fewer guarantees about stability, consistency, and long-term support. Blender's frequent updates can introduce unexpected issues with backward compatibility, requiring additional testing and modifications for studio pipelines. Additionally, studios must often meet strict intellectual property IP guidelines, and proprietary software provides legal protections and clear licensing agreements that make it easier to manage IP. Open-source software can raise concerns for studios around data security, IP rights, and even compliance with software licensing requirements that might exist in high-stakes or highly regulated projects. Number 12. Growing interest in Blender among smaller studios and freelancers. Interestingly, while large studios face challenges in adopting Blender, it's gaining traction among smaller studios and freelancers. Blender's flexibility, cost-effectiveness, and accessibility make it an excellent choice for independent artists and smaller teams, who can easily adapt their workflows. In fact, as Blender continues to improve and release new features, some larger studios have started experimenting with it in smaller capacities or isolated departments, such as concept art or certain types of modeling. Blender's Grease Pencil, for instance, has been adopted for 2D, 3D hybrid animations and storyboarding by some professionals. Now let's talk about the future of Blender in studios. Blender is undeniably on a growth path, and the Blender Foundation, backed by contributions from major corporations like Nvidia and Ubisoft, is working to make Blender more appealing for studios. Its user base continues to grow, and with each new release, Blender is narrowing the gap in features and functionality compared to its proprietary counterparts. Additionally, the industry itself is evolving. Many studios are beginning to experiment with open-source software and are more open to adopting Blender for specific tasks, especially as the Blender community addresses compatibility, stability, and performance concerns. Some industry professionals predict that Blender will continue to gain traction, particularly for pre-visualization, environment modeling, or as part of hybrid pipelines where it complements proprietary software rather than replacing it outright. In summary, the primary reasons why many studios don't yet use Blender involve established workflows, integration issues, a preference for industry-standard tools, customizability, and stability concerns. However, Blender is slowly becoming more viable as the community addresses these challenges, and as perceptions shift, it may eventually find a broader role within the industry. Thanks for watching. I hope you found the video insightful and informative. If you enjoyed it, please like and subscribe to the channel. Your support means the world to me.